Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course. The periodic table. Today we will begin with lecture 15 from the course, but make sure you have watched the previous ones before viewing this one. So we are discussing about the periodic trends and properties of elements, wherein we are going to learn another property today, that is electronegativity. So let us begin with the definition of electronegativity. So electronegativity is well defined as the relative tendency of an element in a molecule to attract the shared pair of electrons towards itself. And unlike ionization enthalpy and electron gain enthalpy, this is not a measurable quantity. So let us understand what we mean by this. We have a hydrogen molecule in which we have two hydrogen atoms. These atoms share an electron pair amongst themselves, one electron being contributed by each hydrogen atom, and hence the sharing of these two electrons between these two atoms of the molecule, right? So this leads to the formation of a covalent bond between hydrogen atoms, right? So what is a covalent bond? A covalent bond is a bond which is formed by the sharing of an electron pair between two atoms. Now if you see the sharing, well, hydrogen and hydrogen atom, they are same to each other, so they will have an equal tendency to attract this electron pair towards themselves. So this means that there is going to be equal sharing of the electron pair between two hydrogen atoms. But this is not the case every time. Consider the example of hydrogen fluoride molecule. So we have an H atom, we have an F atom, and there is going to be the sharing of an electron pair between these two as well, leading to the formation of a covalent bond. But what happens is that fluorine, this has a higher tendency to attract the shear pair of electrons towards itself. So the electron cloud of this HF molecule, this will move towards fluorine. There is not going to be complete transfer of the electron towards fluorine. It is only that the shared pair of electron, this moves more towards fluorine. Okay, so this leads to an unequal sharing of electron pair between the two atoms, that is hydrogen and fluorine. And the electron pair, because this moves more towards fluorine, so we say that fluorine has acquired a partial negative charge, and the amount of partial negative charge on fluorine would lead to the same amount of partial positive charge on hydrogen, because as such the molecule is going to be electrically neutral. So partial negative charge on fluorine and partial positive charge on fluorine leads to the formation of HF being a polar molecule. And now you can understand that where there is equal sharing of the electron pair, this will be a non-polar molecule. Now when we say that fluorine has attracted the electron pair towards itself, so this means that fluorine out of these two atoms is more electronegative, and hydrogen, this will be less electronegative, right? So I hope you understand now the meaning of electronegativity. Fluorine has a relative tendency to attract the shared pair of electrons more towards itself, so being more electronegative, right? And now when we say that unlike ionization enthalpy and electron gain enthalpy, this is not a measurable quantity, we mean is that we cannot measure directly the electronegativity values of an atom. Because this is just a tendency for the electron pair to move towards one element out of the two which are forming a molecule, right? So this is going to be a qualitative term, not a quantitative term, unlike ionization enthalpy and electron gain enthalpy, where we can actually measure the energy changes that are happening. So now let us understand what is the difference between electronegativity and electron gain enthalpy, because basically both of them are a tendency of an element to attract electrons. So what is the difference between electronegativity and electron gain enthalpy is that electronegativity is tendency of an atom in a molecule to attract the shared pair of electrons towards itself, while electron gain enthalpy is the tendency of an isolated gaseous atom to attract an electron. So electronegativity is a property of atom in bonded state, while electron gain enthalpy is the property of the atom in a isolated state. Okay, so this is a isolated gaseous atom. Electronegativity has no units of its own, and electron gain enthalpy, this is measured in kilojoule per mole, kilocalorie per mole, electron volt per atom, whatever desired units of energy we choose. Electronegativity is a comparative value between two atoms, whereas electron gain enthalpy, this is going to be an absolute value for a particular atom. Now let us see the scales of electronegativity, that is how we measure electronegativity. Well, just now I said that this is a qualitative term, not a quantitative term, and now we are trying to measure electronegativity. Well, a number of scientists, they did try to give electronegativity a quantitative meaning so that we can measure electronegativity and we can understand how much is going to be ability of one element to attract the electron pair towards itself when it is in a bonded state. So a number of numerical scales of electronegativity of elements like the Mulliken scale, the Mulliken-Jaffe scale, the Allred-Rochow scale, they had been developed to give a quantitative meaning to electronegativity and hence measure the electronegativity of an element. Well, these are not going to find out the electronegativity value as such of an atom, but they are going to be based on various other data like bond energy, dipole moment, ionization enthalpy, electron gain enthalpy. So indirectly, we are going to measure electronegativity. The first scale we have is the Mulliken scale because this is the most frequently used scale, and this was given by Linus Pauling in the year 1922, and he was an American scientist. What he did was that he assigned fluorine with an arbitrary electronegativity value of 4. And then the other elements he assigned the values of electronegativity relative to fluorine. But the first question is, why fluorine? So fluorine was chosen to be arbitrarily assigned a value of electronegativity of 4, or we can say that fluorine was chosen to be a reference because fluorine has the greatest ability to attract electrons in a covalent bond. So these are the values of the electronegativity when fluorine was taken as 4. Relative to fluorine, this means that oxygen has a lesser electronegativity. Nitrogen will have a value less than oxygen, and similarly chlorine and nitrogen, they have almost same electronegativity values. But remember, if you have to make an order of electronegativity where nitrogen and chlorine both are given, chlorine will be slightly more electronegative than nitrogen. Okay? Both are having the same value 3.0, but if you have to just make an order, do remember that chlorine will be slightly more electronegative than nitrogen. Okay, and what I want you to do is that please remember all these values that have been given in this chart. Only these many values, they won't be sufficient, but they will be really helpful in your problem solving when we will be actually applying electronegativity to various concepts. Now, Pauling, he gave a relationship of electronegativity difference between the two atoms forming a bond and the bond energies of the molecule to calculate the value of electronegativity of various elements. What we mean is that fluorine, for example, the electronegativity value was taken as 4. So with fluorine as 4, taking another element and calculating the value of electronegativity of it, then if that is known, calculating the second one and so on, he calculated the values of electronegativity for various elements using the bond energies of the molecule. So the relationship he used was that chi A minus chi B. This is chi is the sign or the symbol of electronegativity, and here we have the electronegativity difference between two atoms A and B which are forming a bond. Right? So chi A minus chi B, the electronegativity difference, this is equal to 0.208 into the under root of EAB minus the under root of EAA into EBB, electron volt per molecule, right? So this is this formula that he used to calculate the electronegativity. And when he had taken fluorine to be 4.0, for example, if this is fluorine, we know the bond energies of the various molecules. We are going to be able to calculate the electronegativity of element A. And what is EAB over here? Well, this is going to be the energy of the bond between A and B, right? And then EA is the bond energy for the molecule AA and bond energy for the molecule PP. Okay. Now, this was the value when it was taken in electron volt per molecule. When we take it in kilojoule per mole, just replace 0.208 by 0.88, and when it is in kilocalorie per mole, change it to 0.182. Right? I hope this is clear. Now, the important point over here is that Pauling's electronegativities, they are directly related to the oxidation number of the element. What all values he took for the electronegativities of the various elements, these stated values, they are generally for the highest oxidation state of the element. So whenever an element is having more than one oxidation state, the oxidation state which is the highest, so that is corresponding to the values which Pauling gave. Now, the next scale we have is the Mulliken scale. So, Pauling scale, this was the most frequently used scale, but definitely not the most convenient one. So, Mulliken scale, this is quite a convenient scale to use. And in fact, this scale can be used to calculate the electronegativity of a single atom as well. So according to Mulliken, the electronegativity of an element, this is the arithmetic mean of its ionization enthalpy and the electron gain enthalpy measured in electron volts. So this is chi m. Chi m is signifying that the electronegativity according to Mulliken, and this is equal to the ionization enthalpy plus electron gain enthalpy I plus E divided by 2, giving the arithmetic mean. Fine. Now, how do we relate the electronegativity values given by Mulliken and Pauling? So this is the relation we have, that chi p, that is the Pauling's electronegativity, this will be equal to the Mulliken electronegativity value of the element divided by 2.8. So we mean by this is that whatever values are coming for the Mulliken's electronegativity, they are 2.8 times that of the Pauling electronegativity. So we can write the chi p to be I plus E divided by 2 into 2.8 or I plus E divided by 5.6. This is when we are taking the values in electron volts, but when we want to take it in kilojoules per mole, this value is going to be just converting 1 electron volt per molecule into 96.48 kilojoule per mole. So we multiplied here the denominator by 96.48 and we get chi p to be I plus E divided by 540 kilojoules per mole, or if we want it in kilocalories, it is going to be I plus E divided by 130 kilocalories per mole. The next we have is the Allred-Rochow scale. So Allred-Rochow, they were two chemists who came up with this scale, and they basically came up this scale by taking the electrostatic force of attraction exerted by the effective nuclear charge on the valence electrons. So we define the electronegativity according to this scale as an attractive force between nucleus and an electron at a distance equal to the covalent radius. So we have chi AR, that is electronegativity according to the Allred-Rochow scale. So this is going to be 0.359 into Z effective divided by R square, where R is the covalent radius in angstrom. and relation of this with the Pauling's electronegativity is equal to 0.359 chi AR plus 0.744. So this is how the three scales are related to each other. Well, I hope you will be able to remember all these formulas. So that would be all for this lecture. The next lecture coming up is going to be on the periodic trends of electronegativity and the factors affecting electronegativity. Again, a very important discussion. So please be with me for the next lecture. Until then, if you have any difficulty, please feel free to mail us at h2ochemistry@gmail.com. You can put your query in the comment box as well. And if you've liked the lecture, please do click on the like link. If you've not subscribed till now to the channel, do that so at the earliest, because you're going to get a notification only when you click on the subscribe link and the bell icon. Okay, so please do that as well. Have a nice day. Enjoy yourself. See you soon for the next lecture.